Hi everybody, it's lesson number 4, page 617. We're going to start proving trigonometric identities. So an identity is different than an equation. An equation is something that looks like this, and like it says here, it's true for certain values. This equation is only true for when x is negative 2 and 2. But if I take this and I say x plus 1 squared is equal to x squared plus 2x plus 1, it's true for all values, okay? Doesn't matter what number you put in there. Those sides are equal. The left side of the equation, this one, is equal to the right side of the equation. We've already seen some. We've seen that when you're dealing with the unit circle, if you did that bonus lesson, sine is equal to y over r, cos theta is x over r, tan theta is y over x. There's a Pythagorean identity here. We've also talked about reciprocals. Cosecant is 1 over sine, secant is 1 over cos, cotan is 1 over x. And these are all on your formula sheet, which is on the very front page of your book, your textbook. And this is a formula sheet, a scanned copy, a poorly scanned copy. I've added a couple in down here that we will look at, but we won't look at them in this lesson. So we're going to skip all this verifying stuff. We're not going to worry about that. We're not going to prove that. And we're going to look at these. Okay. So these identities, the first ones, quotient identities, tan is sine x over cos x. Cotan, since cotan is 1 over tan, it's 1 over tan of x. That's 1 over sine x cos x. Flip the bottom fraction, and it turns into cos x over sine. You do not need to remember any of these. They are on your formula sheet. Even if we were in class, I would not ask you to memorize these. But we're going to use them quite often, so these ones you will just hopefully come to know. Tan is sine x over cos, and cotan is cos over sine. And the next set are these Pythagorean identities. And if you looked at the unit circle lesson, that was the bonus lesson, these would ring true because you would get sine squared, which is y, and cos squared, which is x. So you get x squared plus y squared is equal to 1, which is hence the Pythagorean, because that's Pythagoras' rule, or equation, Pythagorean equation. From that, you can get these other two. 1 plus tan squared is equal to secant squared, and 1 plus cotan squared is equal to cosecant squared. Again, don't need you to memorize them, just need to know how to use them. All right, you will always have a formula sheet. But these can be rewritten. So for example, if I move the cosine over here, subtract it off, I get this. Sine squared is equal to 1 minus cos squared. Or if I move the 1 over here, I end up with tan squared is equal to secant squared minus 1. The trick is, if you see a trig function squared with a plus 1 or a minus 1 somewhere in it, think about using these identities. And on your formula sheet, they are right here. Okay, basically we're just using all of these. All right, we're going to get to these other ones. This first lesson is just about these ones up here. Okay, so how do you do this? So what we're going to do in these first examples is we're going to take this and we're going to rewrite it. That's all we're doing in these things, is rewriting things. So you need to be good with fractions. I know that scares people. And you need to be good with adding and subtracting of those fractions and finding common denominators. So our goal here is to write each as a single trig ratio, one term. That's all we want to write. And they have multiple ways to do each question. So this first one, sine squared over cos squared. A couple ways to do it. First way is if you have two terms, all right, this is one term, this is the other term, and they ask you to write it as a single trig ratio, you're going to have to put them together. So we need to add these together, and one is a fraction. So to add fractions, you need a common denominator. What is the common denominator? It is cos squared. And since it has to equal 1, all I've done is rewritten the 1 as cos squared over cos squared. Anything divided by itself is 1. So we're good. Now we have a common denominator. To add fractions, you add the tops together. Sine squared x plus cos squared x. The bottom stays the same. And then this is where you hopefully remember your Pythagorean identities. Sine squared plus cos squared. Go to your formula sheet. Sine squared plus cos squared is equal to 1. So this is actually sine squared plus cos squared is 1 over cos squared x. Sorry for the x there. And that is the same as 1 over cos of x. Sorry. Cos of x all squared, because 1 squared would give is 1, and then square the bottom. And 1 over cos is secant x. So this, and it's all squared, so it's secant squared x. That's a simplified version of that. Now, there is another way to do this question. The other way is you see sine squared over cos squared. That is the same as sine of x over cos of x all squared plus 1. Sine x over cos x. Look at your formula sheet. Is tan of x. So this becomes tan of x all squared plus 1, which is the same as just the notation tan squared of x plus 1. We have a function, trig function squared, and a plus 1. So we go to our formula sheet. Oh, 1 plus tan of x, tan squared x, is secant squared. So this becomes secant squared of x. Same thing. It doesn't matter how you do it. It's totally up to you. All right, next one. Sin x plus cotan plus cos. All right. The way I like to do these is you don't want tans and cosine, or tans and cotans. You want to rewrite everything in terms of sine and cosine. So if there's a cotan or anything, get rid of it. Rewrite it as a sine and cosine. This is sine of x plus, what's cotan? Cotan, now you could write it as 1 over tan, or you could write it as cosine over sine. That's the one we're going to choose because we want everything in terms of sine and cosine. So it's going to be cosine of x over sine of x times cos of x. These are being multiplied, so you can just multiply the cosines together because that's like over 1. So you multiply top times top, bottom times bottom for fractions. Sine of x plus cos squared of x over sine of x. Remember, we're trying to make a common or one term, single trig ratio. So now I need a common denominator. We have sine here, so I need a sine on this one. So I multiplied top and bottom by sine. Sine times sine is sine squared, so I end up with sine squared of x over sine of x plus cos squared of x over sine of x. We have a common denominator, add the tops together. Sine squared x plus cos squared x over sine of x. Hopefully you remember by now, sine squared plus cos squared is 1. you have 1 over sine, which is the cosecant of x. So this is the same as cosecant, it's just rewritten. Okay, 3 more examples. So we want to write everything in terms of sine and cosine. Well, we have tans, right? So the top we should write as 2. And what is tan? Sine over cos. So this is going to be 2 sine x over cos of x. Where my formula should go? There it is. And then, we have 1 plus tan squared. 1 plus tan squared. So that's a trig function squared with a plus 1. Hopefully you remember, 1 plus tan squared is secant squared. So I get secant squared of x. What is secant? If you don't remember, go to your formula sheet. Secant is 1 over cos. So this becomes 2 sine x cos x over 1 over cos squared of x. Hopefully you remember how to divide fractions. You flip the denominator. So it's 2 sine x cos x times cos squared x over 1. This cosine cancels one of those, and I'm left with 2 sine x cos x. And that's it. Later on we'll learn that's a double angle identity, but right now we don't know that, so we're done. We've written everything in terms of sine and cosine, which is what they asked us to do. Okay. Factor the following trigonometric expressions. Okay, well, factor. What can I take out of here? I'm going to take 3. Let's cos 4 theta minus sine 4 theta. So then what do I do? Obviously they want us to do something more than that. Hopefully you remember, this is a difference of squares. It's like x squared minus 1, which would be x plus 1, x minus 1. So these are to the 4th, so it's going to turn into cos squared theta minus sine squared theta times cos squared theta plus sine squared theta. And then hopefully you're recognizing that cos squared plus sine squared is 1. So now I have 3 cos squared theta minus sine squared theta. I could write times 1, but pointless. And then you can go one more. This again is the difference of squares. So it's 3 cos theta minus sine theta cos theta plus sine theta. And you can't do anything else with that because we don't have any trig functions squared. Cos plus sine is not 1. It's only when they're squared that it equals 1. Okay, so we're done. All right, last one here. Doing blue. Factor. Okay, what am I going to factor? Hopefully you realize you factor out a sine squared. Sine squared theta, I'm left with 1 plus cotan squared theta. We have a trig function squared with a plus 1. So 1 plus cotan is cosecant squared. So I can rewrite the inside as cosecant squared theta. All right, what is cosecant? If you don't remember, cosecant is 1 over sine. So we got sine squared theta, 1 over sine squared theta. What happens to these signs? They cancel each other out. We're left with 1. All right. Now there is another way to do this one. You could go, you don't even have to factor. They tell us to factor, but you don't have to. Cotan, if you don't remember, is cos over sine. So cotan squared is cos squared over sine squared. And excuse me, I forgot to write the thetas, but I'm running out of room. Sine squared over sine squared cancel each other out. So I'm left with sine squared this guy plus cos squared, sine squared plus cos squared. Hopefully now, sine squared plus cos squared is equal to 1. I don't care how you do it, people. Just practice. So the first thing is convert everything to sine and cos if you don't have it already that way. So if you have a cotan, rewrite it as cos over sine. If you have a tan, rewrite it as sine over cos. Second thing, if you have 1 plus or minus some trig function squared, think Pythagorean identities. These guys right here, see if you can rewrite something as a single term. And if you can, after that, you will either going to have fractions that you are dividing, so you flip the denominator and multiply, or you're going to have fractions that you're adding or subtracting, so you need to make common denominators. All right? Please practice. The only way to get good at this stuff is to practice. So the numbers I'd like you to do are 5 to 16. It's just practice, practice, practice. All right, good luck. Let me know if you have any questions. Thanks.